All right, in this lesson, we are going to look at some growth, decay, and interest applications. Some of this will be a review from our exponents unit, and some of this will be new now that we know log. And so we have seen the growth and decay formula where A is the final amount, P is the initial amount, and then if it's growing, you add the interest rate. If it is decaying, you subtract the interest rate. And then we've also seen the compound interest formula. You only use this formula if you see the word compounded in the problem. If you don't see the word compounded, do not touch this formula. It is only for compound interest. And the n is the only added part to the growth formula. And so if n is 1, you just end up with your growth formula. This would be 1 and this would be 1. But usually it's compounded a certain number of times per year. And so we talked about monthly, n was 12. And so we can write these down. Monthly was 12. If it was, say, daily, it would be 365. If it was quarterly, 4. And then I've also seen semi-annually. Oh, that would be 2. Okay, and then if they say the word continuously, you're going to start using the equation that has E in it. So the only one we haven't talked about is half-life. And the only time you'll use this formula is if they give you the half-life. And so the word half-life will be in the problem. And so it's going to be very easy to tell which formula to use when, and so that shouldn't be a problem. And so starting with our first example, it says you invest $5 at 7% annual interest. Calculate the amount you will have after 2 years if the interest is compounded annually, quarterly, weekly. Okay, and so we know the initial amount is 5. We know the interest rate is 7%, so 0.07 for the R value. Remember, move the decimal 2 places. And then we know T is 2 years. Okay, and so in the case of annually, N just equals 1. And so my formula is going to be P1 plus R to the T because N is 1. And so here, actually, I'm going to go ahead and put N into the formula just to get practice with it. So 1 plus R over N to the NT. And we're going to use this formula 3 times because the word compounded. Just with different N values. Okay, and so in the case of quarterly, we're going to use N equals 4. In the case of, oh, they gave us a line for that. N is 1, N is 4, N is 52 for weekly. And so in each of our formulas, P is going to be 5, and R is going to be 0.07. In this case, N is 1, and T is going to be 2. In the second example, P is still 5, R is still 0.07, but now N is 4. Remember, N shows up in 2 places in the formula. And then lastly, we have P is still 5, R is 0.07, and N is 52. And so for continuously, we use a completely different formula. That's when E is going to show up. And so P is still 5. E is that constant. There's a button for it. And then R is 0.07 and T is still 2. And so a way to remember this formula is PERT. It says PERT, but the R and the T are in the exponent. Okay, and so in your calculator, this calculator app looks a little bit different than yours, but the buttons are pretty much the same. And so to calculate A, we're going to type 5 parentheses 1 plus, and to get that fraction, you can do alpha y equals enter. And so 0.07, and it's not really useful for this one because n is just 1. And then to get in the denominator, then close the parentheses, jump up in the exponent, and type your 1 times 2. Okay. And so we get $5.72. And so remember, keep 2 decimal places for these because it's money. So $5.72. Okay, for this next one, we just need to change the 1 to a 4. And so if you want to, I think you can press second enter. It will re-enter your last entry, and you just can change some numbers. So we just need to change the n value. And so I am going to delete and change those 1s to a 4. And so we get $5.74. And then for weekly, we just need to change the 4 to a 52. So second, enter, and change this one first. I think you can just override. On this app, I have to actually delete it. But be careful when you're overriding and you have less digits. You might override something you don't want to. And then $5.75. And then for continuously, we have to type in 5 and then second ln. It automatically puts E and then raises to an exponent. So you just type the 0.07 times 2 for that formula. And so $5.75. Okay. And so for this next example, a radioactive isotope has a half-life. We know we're using the half-life formula of 8 days. This means that half the substance decays in 8 days, so half will be remaining after 8 days. If 4.8 kilograms are present now, how many will be present after 5 days? How many after 2 weeks? Okay, and so our half-life formula is this formula here, where T is still time and K is the time for the half-life. And so you have to make sure these are measured in the same unit. So if it's years, you use years. If it's days, you use days for both. And so same units. And so you may have to convert your units to make sure that's the case. And so it's T over the half-life. Okay, and so because I see that word half-life, I know I need to grab the half-life formula. Right, and so we're starting with an initial amount of 4.8 kilograms. I'm going to leave the units off. And then the half-life value is 8 days. I am going to write the units because I need to make sure my time is measured in the same. And so first we're going to find 5 days, and then we're going to find 2 weeks. And so that's what we need to convert to days. That would be 14 days. Okay, and so for the first part, we're going to have 4.8 times 1/2, and you could do 0.5 if you wanted to. And then we're going to have t, which is 5 over 8. In the next part, I'm going to figure out the same formula, only now the number of days is 14 divided by the 8. Okay, and so 4.8 1/2 raised to the 5 over 8. We get 3.1, and then let's keep 3 decimal places since they didn't specify. And then our units are kilograms. And then we need 4.8 times 1/2 raised to the 14 over 8. We get 1.427. Okay, so that's how much would be remaining after 5 days and then after 14 days. Since the half-life is 8 days, you still have more than half remaining after 5 days. We have less than half after 14 days. So these answers make sense. All right, next up, we are now going to use our formulas, but this time we're solving for time. And so our first problem says you deposit $1,000 in an account that pays 5% annual interest compounded continuously. How long will it take to reach $1,500? Okay, and so we know our P is 1,000. We know A is 1,500. We know R is 0.05. And then we don't know T. But we do know we're using the PERT formula because it said continuously. Okay, and so I can plug in the information I have. And then E is not a variable, it's a constant. There's a button for him. And then 0.05 T. And so we need to solve for T. And so our first step is to isolate the exponential expression. And so we need to divide by 1,000 first. Okay, and you can leave it like that for now. And then we have e to the 0.05t. There's going to be a lot of decimals, and you only want to go to your calculator one time. You don't want a lot of rounding mistakes because you'll be off by a lot if your rounding accumulates. And so once we get to this step, we have our exponent isolated, our exponential expression isolated. We're ready to convert to log. And so my base is e, my argument is this fraction equals 0.05t. Since my base is e, we know we're using natural log of the 1,500 over 1,000. And you could simplify that fraction if you wanted to, equals the 0.05t. And so we're almost done. Our last step is to divide by the 0.05. Okay, and so if we didn't have a calculator, you would have to leave your answer like this, maybe simplify the 1,500 over 1,000. But you want to completely solve for your variable before going to your calculator so you don't have any rounding mistakes. Okay, and so natural log of 1,500 divided by 1,000, close parentheses, divided by 0.05. And so we get 8.109. And then they didn't say what to round to. And so we'll just keep 3 decimal places and add our unit. So after 8.109 years. And that makes sense to take about 8 years to earn $500 extra in interest. If you get something negative or something like 8 million years, something's wrong. And so it's got to be a reasonable answer. Okay, I think this is the last one. You deposit $200 into an account that pays 7.5% interest, compounded quarterly. How long will it take the balance to reach $2,400? And so we know our final amount is $2,400. Our initial amount is $200. So that may take a little bit longer. We know R is 0.075. We now have N, which is 4, because it's compounded quarterly. And then T is our unknown. So we see the word compounded, and it's not continuously, so we need the compound interest formula, the one with N. And then we can fill in the given information. So we know A is 2,400. We know P. We know R. We know N. We just don't know T. So we are going to want to simplify this as much as possible. And so first step is let's figure out what this decimal is. And so I'm going to do 1 plus, I'm going to do the fraction just in case, 0.075 divided by 4. So we get 2,400 equals 200. And then inside the parentheses, 1.01875. No rounding. Got to keep all that. Okay, and now we're kind of back to what we did in the last problem. So we want to divide by this 200 first, and this will be a nice number. 2,400 divided by 200 is just 12. Okay, and so now we have our exponential expression isolated. We're ready to convert. And so this decimal is our base of 12 equals 4t. So log base 1.01875 of 12 equals the 4t. And then our last step would be to divide by the 4. Okay, and so t equals log base 1.01875 of 12, all divided by 4. And then when we got that number earlier, you could actually store it in your calculator, but I'm just going to retype it. So I'm going to get a fraction. Alpha y equals enter. And then to get this base, a different base, you have to press math, alpha, math. And so now it lets me type a different base. So 1.01875, that's my base. And then my argument is just 12. And then we're dividing all of this by 4. Okay. And so about 33 years, so 33.44, and then that 1 gets rounded up to a 2. And so 33.442 years. And that's a reasonable answer to be able to make that much money.